Hello, Chapter 10, Modeling. We are going to focus on the various models existing today in software engineering. This is more focusing on sort of UML type and object-based modeling. That's very important for management because when you model things, that means prior to building a product, you visualize it. It's kind of like building a chair. You first want to draw the picture of a chair. What is the seat? What is the back? What is the legs look like? And then from that one, you'll set it up for basically requirement design and development. So, like every project, even when they try to build a high-rise building or an airplane or even suits and dresses, you first model it. You build the first mock-up, and based on that one, you follow up the details. So software doesn't have physicality to it, it's more code. So what do? We use a lot of modeling. We try to draw things, and our only purpose is really, there are really two purposes which yields to one item at the end. What are the pieces you're trying to build? I mean, how many pieces of functionality, components, etc. And most importantly, how can you communicate that with your customer, your client, the ones you're building the product for? You're going to tell them, this is what I'm building for you. This is why it's going to take 2 years and it's going to cost that much, right? So we're going to do a survey of this one. So as I said, there's two aspects. Also, your developers need to be able to learn UMLs or RUP. Remember, we talked about RUP, RUP already. We're going to talk about UML today a little bit. So basically, let's go ahead here. There are some classical modeling techniques. Okay, there's one we call it entity relationship modeling. We call it ER or ER diagrams. Everybody sort of, you probably have heard of it. Another one we call it finite state machines or data flow diagram, DFDs. I worked for corporate for many years, and all the time there wasn't one day as a technician that somebody wasn't asking for the DFD, data flow diagrams. And data flow is everything in the program because think of an ATM. The data flow is the important thing. What goes in, what comes out. There goes in card plus your PIN comes out validation, then goes request for cash, comes out cash. So DFD shows the flow of information. We also have this thing called CRC cards, which I'll talk about all of these. And then also we want to focus at the end on some object-oriented modeling. So this is actually what I was telling you, UML. That's the latest one. So as the classic ones have been around for a long time, since 60s and 70s. UML has been more into the 90s and beyond. So all of them are very strong in their area, heavily used. So I'm going to just brush through all of these. This is the way it is because you need to know really the terminology. Okay. So first of all, I'm going to go back in a format that I usually do. This is a very important slide, so you need to know these terms on this slide. Okay. Okay, so first of all, on the ER, or entity relationship modeling, entity is any distinguishable object of some type. Okay, so entity type is a type of that. For example, in a library, an entity could be a published material like a book, or an entity could be an order. Okay, so order is actually a relationship we're going to talk about on this one. So the entity type is very important. At the university, an entity could be a department, could be a course, could be a professor, could be a student, and of course we have relationship with each other. A professor teaches a class versus a student takes the class. Okay, so all of these things, library lends you a book, but you borrow a book. So it's called various aspects. So we have this thing called attribute value. So pieces of information, typically partial information, describes an entity. For example, a student at the university has a name, has a MAV ID, entry year, status graduate, undergraduate, but that's also partial because, how far have you completed? What is your GPA? Those are, we don't typically reflect. That's why we call it partial. We also have attribute types of sets of attribute values. As I said, okay, this student's GPA is 3.7, so this is a value. Of course, relationship association between two or more entities. So these are pretty rudimentary items. We also have this thing. This is a typical ER diagram. So if you look at here, for example, this is the boxes here are entities. Okay, a member is an entity, a book copy is an entity, but each one of them have attribute types, attributes. For example, a member has a name, address, identification, okay? Versus a book also has an ID. And the relationship is here. For example, a member borrows books. So also affinity here, for example, you could borrow as little as no books up to 10 books. I mean, if the library, for example, says the maximum you could allow is 10 books. So that basically means a borrower, there's only, since this is a copy of a book, there's only one book. So you can never borrow one book more than 2 times, right? So if that's the book, if I borrow it, it's gone. So that's why we say it's a copy of a book. So maybe library has 10 copies of the book. So you go there and but I'm looking at one book here, one copy. So I only borrow one book because when it's borrowed, it's gone. So you can see very simple. And the diagram is pretty much it is. It's a very powerful one. So if you try to design a system, you kind of know you need to have a few things. You need to have members with these attributes, books, IDs, and a relationship type. So that's pretty much, this will yield to a requirement, which I'll cover next week in the next chapters and so forth. Next one is called finite state machines. These have been around for a long time too. Actually, we've modified this one, and UML, which I'll talk about it, they came up with this thing called a state transition diagram, or STDs. Those are pretty much like finite state machines. So the finite state is the grandparent of that one. So models the system in terms of states transition between them. It's a very dynamic. Actually, if you ever taken an automata class, you see it's a finite state machine. That means you change the states. I'm here, you push me, I go there, I'm there, you push me, I'm coming here. So you sort of flip flop or go back and forth. Typically, for example, if you have a video game, the AI of the game is written or drawn using a finite state. Okay, if you press this button, the game starts, and then you go to this level of difficulty. If you press letter T, a gun is fired, or enemy is dead, or you get that many points. But it never ends because you could repeat things multiple times, right? A game goes to this repeatable state. That's called finite state machines. It's often depicted as a state transition diagram. This state transition is actually a new term that UML came, so we made it to more of an object base. So each state is a bubble. So we typically, I want you to know the notation. Each state is a bubble, and each transition is labeled as an arc. Okay, so transition is an arc, state is a bubble, and in large system, large diagram, hierarchical diagram. Let me just show you one of them here. So this is a typical state transition diagram. As you can see, bubbles, okay, are states, okay, and these arcs are transitions. So just go, as you can see, you could keep changing a state. For example, a book copy present. Now you lend it to someone. Now it's no longer present. Then you return the book. Now it's present. Okay, so what happens to this book forever? It just it's on the shelf, borrowed. It's now not no longer on the shelf. Returned. It's on the shelf. You see, it's a state transition. So a borrowed may be also, let's say I borrowed a book, and now instead of returning, I don't want to return it. I can keep this for 2 extra weeks. So I can just renew it. So this is without returning it, I can renew it. Or I can, hear a book present. Maybe what happens after a book gets borrowed many times, maybe it gets damaged. Okay, you may throw it away, or maybe send it for repair. When you send it for repair, it gets repaired, sent back. So you can see how the state changes, right? And at some point, if you say you have borrowed something and you sort of write it off, in other words, maybe you lost the book, right? I've done that many times, and then your library says, "Hey, you owe us $50 for that book." So you never return it, you never renew it, you never. This is sort of determination. So it's kind of think of a game also like this way, right? So state transition diagram, because we have states and we transit and go back and forth. Okay. Okay. The other one is we call it data flow diagrams. Extremely popular in all, especially industries, companies like Boeing's and insurance companies and banks. They all use data flow diagrams because really they want to show the flow of information. Right? How does the information flows from one state to another? So we typically entities, external entities, we show them as boxes. Now the color doesn't matter. It's just like, but the shape is very important. Processes, we show them as circles. Data flow, we show them as arrows. Okay. And the storage, we show them as two lines on top of it. That basically means like a database. But we don't want to use database because database means a lot more. It means you keep the data permanently, means you back it up, means you renew it. But data storage means maybe this is just a short document, right? For example, your homework assignment 2, you don't want to say I checked that to a database, but you store it somewhere because as soon as you get grade and the course is over, you probably throw it away, right? So that's why we put data store. So just notice these notations for them. So let me just show you data flow diagram. So think of this is actually, you see this very common if you join a lot of corporate. So think of this one, for example, and this has, you could actually segregate, separated by the type of user. So think of, in any company, you have probably clients, okay? Those are the one who pay you, and you have your development team or your management group, okay? So let's say what happens. This is just to show things here. As far as notation goes, first of all, it's client management. Notice this one, okay? We call these entities, right? Then we have circles, right? So we call those circles processes. That basically things they do activities. So here I have a client, I have a manager, I have a preliminary document that I create. Maybe I borrow a title, maybe there's a preliminary document that I modify. Notice this preliminary document has been used many times, but remember, it's been added to it. It's kind of like I create a document. The first day is only one page, but by the time I'm done, it's many pages. So I'm writing a proposal. Here's 2 pages, okay? And then managers start reviewing and add more, and maybe you add more. So notice things can get repeated all the time. Okay, for now, I'm just showing you notation. Notice these 2 lines is a log file. For example, if I want to know who is updating this file, okay, it's very common, is who's writing this file. It's a log file. Or maybe later on I want to catalog this one. I want to keep it permanently and make it available to others. This is also storage. So, and of course the arrows, as you can see here, are basically the flow of data. So let's say in here, a client makes a request, right, to create a document. Maybe this is a requirements document or a specification for the project. So I start putting things together, okay? And then what you could do here, you maybe log this data. So you're gonna say, hey, it's the first version I've created. You put in this one. And then when you put it to the log, okay, so now it's written to the log. So notice the output is log file. So what is the input is the request. The output is a log file. So this is, whatever you do in this document. Maybe it's a proposal to do a project, or, Khalil is a client request for this homework and you do your homework. So now you're gonna check it to this log file. Now manager, this needs to be made available. Okay, manager says, hey, let's see what you've done. Or Khalili wants to grade it. Say, hey, let me see what you've done. So I go to the log file and start getting a report. And I read it. It says, oh, okay, then I give you some set directions. Okay, please add more or change things. Okay. So notice once again the output, the input. Okay. Now after a while I may keep adding things more to this document. Okay. And maybe when I'm done, I just catalog it and say, hey, you sign, I sign, everybody sign, no more updates. So we do this one. And then maybe, sometimes if another project wants to borrow you a copy, you could just lend them a copy of that one. So that's really not matter what the content is. It's just the notation I'm focusing on. The process, an entity, relationships, and also this one. This is really very similar to the previous one, a state, bubbles and state transition. It's just different ones. Is it one better than the other one? Well, is a BMW better than a Benz? They both do the same thing. Okay, so one may be faster, one may be most prestige. It's just the way you need it for what purpose. Okay, same thing for your projects. No, CRCs. These are some of the oldest one. Actually, CRC stands for Class Responsibility Collaborators, not collaboration. This is, by the way, very important, this slide. I want you to remember this. And also, I will not ask you to create this one, okay? But remember, what is data flow diagram? I want you to remember these four things. Entities, whether it's external or internal, everything typically external. Processes, data flows, and basically data storage. Okay. So in CRCs, and once again, these are just different things for the same purpose. Sometimes you use one versus the other. I'll tell you which ones you may want to use for what purpose. Some companies commit to CRC. Everything they do is CRCs. Some commit to, for example, entity relationship with state machines and so forth. So first of all, a class has a name, okay? By the way, this looks awfully like a class in UML. I'm going to show you a class in UML shortly, exactly, but this came way before UML. So when UML was created, a lot of it was copying stuff from the past. For example, a state transition diagram was nothing but this one, the bubbles and the states that I showed you a second ago, this one, okay? This is sort of the birth that UML started using. CRCs, we started using CRCs of class responsibility collaborators as class diagrams. Okay, so they're all pretty much used as a basis for the other one. So first, a class has a name, has responsibility, and has collaborators. So what is the name of a class? Is called reservation. Responsibility, keep a list of reserved titles and handle reservations. Okay, for example, this is in a library, you want to reserve a book. Okay, and then finally, collaborators. Who deals with this reservation, basically entity, or a catalog, because people want to use it, and a user section. So because a user session, so a user wants to, for example, student goes to borrow that or reserve that book, and you look at the catalog. So this is called CRC. It's a bit older, but still a lot of companies have them. It's just some different modeling technique. Okay. So intermezzo, which means something in between. What is an object? Okay, so this is really, all of these were older technology. That's we call it classic. If you notice the second slide, I said those are classical views. Classical means typically older ones, right? Is that mean they are bad? Well, they're not, but they probably have a better one. So the better one today, we use UML. Um, so then we started defining an object. Why? What's an object? Let's once again review it. Most of you are object experts, but just in case, object mimics real world, right? Think of what it is. We are all human, right? So we have basically a class called human, or a class called planet or plants, or a class called, I don't know, fish, or a class called cars, right? So this is real life, right? So then, or a class called student, or let's think of a university. A university has a class called professor, a class called a student. So why is it a class? Because it's repeatable. You could have many students. You could have many professors. So it's a class. Human, you could have many people, or fish, you could have many kinds of fish. Now, this is not everything can be looked this way. For example, designing an aircraft. I mean, you think of your Boeing. How would you do? An aircraft is an aircraft with some engines. They're not gonna keep changing it. It's not like a university where the students come and go. So what's an object? Object is one entity of that class. For example, if there's a student, James Johnson is an object, or Ravi Patel is an object. So object is one member of a class. So please remember, these are fine terms, very simple, but you have to use it in the right way. So class is a category, like a student. Object is one particular student. And of course, you have a state. So the next thing an object has is a state. What is the state? Think of a student. A student could be a freshman, could be a graduate. Even if you're a graduate, your state will change, like a human. Human state changes. Okay, so we have a class called human. Now, Khalili is born. Baram is born. Okay, so I'm an object. They gave me my social security number or my birth certificate. Now this object is created, right? Well, I go through state changes. I'm an infant. Then I go, become a kid, elementary school, high school, then professor, then I retire, then I die. So this is a process. So I change states. So therefore, three things we have to keep in mind. First of all, the class, which is a total category, and object is one. By the way, to create an object, we call instantiating an object. That means you were born, okay? Or destruction or destroying or freeing an object means it's gone. Sometimes an object is not freed or destroyed. Sometimes it changes state. For example, think of a student at the university. When you enter, okay, I have, you're a student class and your name is this, I'll give you a MAV ID, but then your first year, then your second year, sometimes you may go to a PhD program, then third, fourth, fifth year, you go to your PhD or your MS. Am I going to terminate this object? Well, you're not. You just change it from student class, go to alumni class. Now you're part of the alumni class. So now you're in that one, right? So, and you're forever alumni. It's not like, since you graduated from the university, forever you are going to be affiliated with that university. And that's the way it is. So sometimes an object terminates, but sometimes it just changes states or changes class. We have a lot of people who at the university, think of Chris McMurrow, for example, one of my favorite guys. He was my student in his class many years ago. Okay, so he was a student. Okay, he entered, he was admitted. Well, he then became a professor. He's now a professor in the same department. So he changed it from this one to that one. So remember then, I have three things: a class, an object, and a state. This concept called object oriented. So everything, we look at the whole thing in our object orientation. So, but once again, not everything can be OO'd. Like designing an aircraft, there is not. I mean, if an aircraft, so somebody says there's a class called airplane. Well, then what's an object? Well, you could say 747, but that class is there. I mean, you're not going to change the states, right? There's nothing, there is nothing that you'll do. An aircraft has four engines and it stays there. So it's not you may say, hey, I change the engines every 15 years, but it's not really well defined. So in these cases, you probably are better using a DFD or some other models as opposed to an object base. So now that you know objects, so the modeling, if you think of a viewpoint for modeling, model part of the word using basically the stuff I just told you, identify the state and behavior. Sometimes we think of it from a philosophical point of view. This is called existentialist abstraction. Everything is an object. So if you can touch it, if you can feel it, it's an object. So the concept of existentialists, which is actually a philosophy, I don't want to get into it, is there's a concept. If it exists, if physically exists, it exists. For example, things like value, ethics, love, those are not objects. Why? Because there is no physical existence to it. A car is a physical existence, but maybe love or religion or ethics or value, those are, so that's a different thing. That's why there's a lot of things. So in a philosophical point of view, from a software engineering, we look at everything from a data point of view. From an implementation, we look at it structure in memory, like the data structure. And from a formal, we look at some kind of a state machine. So, but all of it is an object. So what does that, all of these means, right? For example, Baram Khalili or Ravi Patel is an object. So let's look at it from these views. From a modeling point of view, so who am I? I'm a professor. I'm slightly overweight, or you're thin. So this is sort of from a modeling point of view. Okay, what's from a philosophical point of view? Oh, he's a very good guy. I mean, he participates, he trains the students. So, or this guy is not a very good guy because he doesn't do the very good things. From a software engineering, I abstract myself. You know me, but you don't know a lot about me. You just know a few things about me. You don't know what I think, what I like to eat, where I like to go, where I have been, who's my family. So really, you just need this called abstraction. You know as much about me as it's necessary for you to know. For example, in software, when we say write or print, I mean, to print something, you need to know what kind of a printer, what kind of device driver, etc. But you abstract it. It's kind of like when you go on a vacation. You say, hey, for a week, we are going to go on a vacation. You're abstracting. Because if you want to open it up, it's going to be like 5 pages. When are you going to go? When are you coming back? Are you flying? Are you driving? If you're driving, who's driving? Have you booked? Have you booked the airplane tickets? All of that. So these are a lot of stuff you have to look at it. But when you abstract it, say, hey, for now, let's go to dinner tomorrow night. Whom are we going with? What time? Which restaurant? We abstracted. And abstraction is your best friend. If you don't abstract things, there's so much information that you will not be able to get yours through. You just have to sort of open the little piece as you need it. For example, when I'm modeling a car, designing a car, I'm just going to say there's an engine. I'm not going to open up how many, an engine could have a million parts to it. But if you want to think about it that level, you never design a car. But if you say there's an engine, there's a transmission, there's a battery, there's a steering wheel, you're abstracting from software engineering. And of course, from implementation, how do you implement this thing? Okay, now how can I make this car or how can I make this engine? And of course, from a formal viewpoint, this is how do you represent it to the formal world. People, when they have a car, they're not going to say, well, this has an engine and this. Of course, it does have. That's a software engineering view. From a formal view, you could say, well, this is a cool car for you. It's a Benz, so or it's a BMW and the price. So this is more of a formal view. So as you can see, everything has different views. Like you, as a student, you're a student from my point of view, but you're the son of your father, so it's a different. But you're the husband to your wife, but you are, a client to a grocery store, and then you are a charity worker to a children's hospital. So this is all different viewpoints. All matters. Which one are we? All of it. But what is important? Well, what's important? What's at hand? Okay, when I'm trying to book an airline ticket, the only thing I need to know when I go, when I come back, what is the duration? So that's all I need. But when you book the airplane, then I have to think of the hotel, and then I gotta look at my budget. I've spoken enough of this one, so you probably get what I mean. So I just talk about objects. So this one, and we also have attributes, right? For example, I have a class called student, and object is Ravi, or it's James or Rodrigo. But then you have attributes, the things that we used to call them tombstone, things that actually identify. So a student has a name, address, email, ID. These called attributes, okay? So object is characterized by a set of attributes. For example, a table has a top, a leg, or Kalili has a name or an ID. So in an entity relationship model, attributes denote intrinsic properties. That means they do not depend on each other. They are descriptive. So intrinsic pretty much is part of that one. Like when somebody looks at you, it knows you're a human. You don't have to explain it, right? So in ER, model relationship denote mutual properties as well. First, for example, the membership of person of some organizations. But in UML, these relationships are called associations. Okay, we will talk about UML in a second. For example, in UML, what is strong about UML? Objects, okay, you might be associated with each other, but in UML, you could actually measure the level of association. Just think of, for example, in a classroom, okay, students are associated with each other, right? Because you're in this class and your friend is in this class, so you're associated, okay? But let's say, what if you have Somebody one day comes to the class and sit there, or you have a guest professor. Is this an association? Well, it's a weak sort of associations. We call that dependency. But let's say what happened if one of you is married and your wife or husband is sitting in the room. Is it a still association? Well, it's a strong form. We call that aggregation. Kind of that's the way UML separates it. So any relationship, we have three: a normal relation, a strong and weak. It's kind of like, think of in the society. You have a very weak relationship to a taxi driver, or you have a very weak relationship to an Uber driver because you just see them for an hour and they're gone. But they're there. I mean, you cannot deny them. But then you're related to other people. Like you see your neighbor all the time, or you go to the local grocery store, so you're associated. But then you live with your wife or your husband. So that means you're strongly associated. We call that aggregation. So formally, UML does not distinguish attributes and relationship. Both are properties of a class. So that's extremely important. So that's why UML actually started to become very popular, because of these levels that I'm explaining for you right now. So think of an object, as I said before, I've already gone over object as an state, okay, which we discussed. We have a class, and of course we have an instant, which is an object. For example, Kelly, that's why we call it instantiation, because you create an instant. When a mother gives birth, that's an instance. So that's why we call instantiation here. So behavior is described by services and a set of responsibility, and services involved by sending a message. So typically in our world, we try to send each other's messages, and that's the way we communicate, right? So relationship between objects, okay? So that's I just covered that one for you. There's different type: weak relationship, strong relationship, association, but there are other ways we could look at it. For example, specialization, generalization. For example, for example, a dog is an animal. So when you talk is an animal. Okay, so this is another way I look at it. Khalili is a professor. Okay, Khalili is a teacher, but is also, okay, a husband to someone. So for example, we also have this thing called whole part, which we call it halves. So a dog has legs. Okay, so notice a dog is an animal and a dog has legs. They are two different things, right? Also, aggregation of parts into a whole. That's when I just talked about the strong type of relationships we talk. So there's distinction between real world, part of, and for example, let's go back here, sort of a little bit more of a representation of things. For example, a publisher as part of a publication, or a member of has a soccer team, has players. Okay, so these are types that we discuss. Now, once again, in why are we discussing this in software management? Because this is how we express things. This is how we draw things. You draw it, then you tell your customer this is what you want. Because if you don't, you're gonna be in trouble, right? Why would you be in trouble? Imagine, okay, your customer comes and says, "Hey, listen, can you build me a tall, I don't know, a tall building?" Or then you build him a 5-story building. So is this tall? I was thinking of a 50-story building. Okay. Or this is my favorite example. If somebody says, "Oh, a tall guy with a blue hat came," okay, well, that means different things to different people. Maybe your client, a tall guy to your client, maybe a 6-foot person and with a navy blue, but maybe I'm very short. When somebody says a tall, maybe I think of a 5.2 versus that. So that is why we have to be very, very careful as far as the precise definitions. So when you model things, exactly know you and your client. So when your client says build me a building, and you show them a 5-story model, that's why this is a modeling chapter. It says, no, 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 this is not what I want. I want to add 15 more levels to it, add a parking, add this, add that. Okay. But are you designing? No. Are you coding? No. You're just creating the model. But the rest is easy. The moment your model is there, it's gone. Have you noticed sometimes you go to buy in a new complex, they have a model of the complex. And then you pre-purchase an apartment, which will come 2 years later. But at least exactly know what is your apartment, how far is it, how big is it, How close to the swimming pool is it? How many rooms does it have? So this is basically another thing we call it specialization generalization relationship. So usually expressed in sort of hierarchical. For example, if a tree is a single inheritance, F is a DAG, is a multiple inheritance. So these are things I'll talk a little bit about single and multiple inheritance. Well, maybe right now. Okay. Often we inherit things from a superclass, right? For example, a child inherits things from their father or their mother, okay? So it's called inheritance. Or think of a university, right? At the university, maybe I have an entity called user, university user. Now I have three separate classes, a professor, staff, and a student. We all inherit from a user class, university user. So I can put all common stuff. Every university user has a name, MAV ID, address, phone, but then a student inherits from that class. So, but I have to add things, right? For example, a student has all of the things that the university has, but also has a major, okay? Or is it the second year? Is it grad or undergrad? Professor has the same thing, but then has tenure status or which department. So this is we inherit. Now, multiple inheritance is when you inherit from two classes. Imagine if a student was inheriting from a university user, but also was inheriting from your, for example, a department society. Okay. Now, often multiple inheritance causes issues because the superclass is the one you inherit from, they might contradict. Let me give you a funny example. Since object orientation and objects typically mimics real life, let me tell you this true real life example. It may sound funny, but it really is true. Think you're born, right? So you've been instantiated by your parents, right? So your mom and dad gave birth to you. Of course, your mom did, but your dad probably had something to do with it, right? So now you're born. So you're inherited from whom now? You can't say from your mom. You're inherited from your mom and dad. So this is multiple inheritance. It's not just one. So now you see where the problem is. You want to have all the features your mom has, and you want to have all the features your dad has. Well, your mom wants to be a very nice, soft, gentle, not war loving, we call it the feminist sort of attributes. But then your dad wants to be a tough macho, beat the crap out of everybody and be a really tough guy. See, that's a contradiction right now. What one class wants versus another class, and you're inheriting from both. And that's extremely, extremely difficult. I mean, we have this thing called conflict of interest. That's multiple inheritance. For example, if you were, okay, in a bank, or let's say even at the university, you're a member of the university, but also if you're a member of a society who reviews the university, then it would be a conflict of interest, because if you pick on the university, it's the other side of you because you're a member of it. But if you don't pick, it's going to be complicated. So that's why we often say try not to use multiple inheritance. For example, if you work, a better example at the university, let's say you're a student, okay? So you inherited from a university, or I'm a professor, or inherited from a university user, but you're also a member of Shorthorns. So it's a publication writing news. Now, one day you need to write something bad about a student or a department. What happens then? On one side, you're a student, but on the other side, you belong to this newspaper group. So what you could do in one could conflict with the other one. Just like I said, a parent, a feminine features and masculine features that a kid inherits from their parents could ultimately contradict each other. So we have a lot of common attributes, which, as I said, is good to put in those. But you have to see how complicated things could get. So Unified Modeling Language, or UML, is a very popular one. It's controlled by an organization called OMG. Please remember this slide and the next one, a dozen structures on this. OMG stands for Object management group. It's a consortium. It's a consortium, which means, first of all, it's a non-profit. It has members from government. It has members from industry, from university. Some of the big members are UT or Carnegie Mellon. Some of the biggest industries are Microsofts and Googles and US Air Force. Anybody who has to do with software generation or Software Engineering Institute in Pittsburgh. So OMG is a consortium which sets rules, and they do a lot. Like Waterfall is designed by them, or UML, if you talk about spiral model versus incremental model, all of these models are typically by OMG. So UML has been around for a while. They had UML 1 and then UML 2. The latest one, typically there are 13 diagrams. Okay. And these are things like a state diagrams or dynamic diagrams, but most often used are class diagrams, okay, and use case diagrams. And these are there because they often have loose semantics. Loose semantics is your friend. That means you could interpret it any which way you like. Okay, so this is, I want you to remember this one. UML basically has static type diagrams. These are like class, deployment, component, object. That means if you just want to show things, no behavior. Like at the university, if you want to say there's a professor class, there's a student class, there is a staff class, there is a course class, there is a section of a course class, there's a payment class. You just show that one, right? Or maybe component. What are the components of a car? Okay, engine, this. It's just fixed static parts. But sometimes you need to show behavior, right? Dynamic behavior, like state transition diagrams. Like that I said, I eliminated the diagram from these because these are all diagrams. The diagram is written here. So activity diagram, communication, composite, sequence, timing. We're not going to cover all of these, but these are when you want to use dynamic behavior. For example, how does a student make payments at the university? That's really more of a dynamic activity versus how many classes a student takes. Well, that class doesn't mean the class here. I mean, let's call it courses. How many courses student has, that's more of a static versus how would I make payments or how would I, for example, graduate. So these are the ones that you kind of know. The most famous ones in this one is the state machine or state transition diagrams, sequence diagrams, etc. Those are important ones. So UML diagram depicts the state structure of a system. So it's most common. We have subclasses, superclasses, and this is supposed to be, remember I just showed you the classical ones like ER diagrams. So this is really entity relationship, often called object orientation. So everything, so UML is an object oriented way of looking at the word, as opposed to, for example, an ER diagram, it's not objects. So in other words, and remember we discussed basically various different types of objects that we are trying to do. Okay, so let's go next to, this is a typical class. Okay, so I have a book, I have a journal. So a book has, for example, let's go back here. A book has I'm trying to turn my phone off here for a second so it won't ring. That's what they do exactly when you don't expect them. Okay. All right, it won't ring anymore. Okay, so this is a typical class, right? It has a class name, attributes, operations of a class. So we have a class book journal. And notice this sign means inheritance. This is not a UML class. I'm not going to teach you exact UML, but this is, for example, says a book inherits things from a publication. So anything is a publication. A book is a publication. So is a journal is a publication, right? Like I said, a student and a professor, and this is a university user. A student is a university user, so is a professor, so is a policeman at the university. So these are some examples of class diagrams, different types of relationships. So we have a library and a client. And for example, a client is a member of a library, or a client is, so this basically shows different types of relationships. This is just items, not that important as far as exam goes. But this is how you draw things. Remember, since software is generally code. It's not like building a bridge. When you build a bridge, you could go there and look or draw it. But in software, we use these types of diagrams to show behaviors. Remember when I said aggregation, like for example, a person is married to another one, or let's do another aggregation. Think of a homework solution to a homework. That's aggregation, because the solution to a homework doesn't mean anything if you don't have a homework. So that's why we shoot these diamonds on it. And remember, what do you do when you marry someone? You put a diamond on their finger. That sort of takes notion from there. So if you see a diamond, typically means I need it or forget it. Okay, so for example, a section of a class needs that class. For example, CSE 5325 section 001. Well, if there is no CSE 5325, section 001 means nothing. So that's an aggregation. Okay. But a professor to a student is an aggregation. It's not. It's more like an association. Doesn't matter if I am your professor or somebody else. It might be better or worse, but it doesn't. Like this class might have 3 sections. So that's really association. If you put an aggregation, that means we must have Khalili teaching this class. Otherwise, it's not valid. So it's not. So that is why we have to. For example, a section of 5325 is an aggregation because section 5325.001 is an aggregation of 5325, because if there is no CSE 5325, the section doesn't mean anything. But professor student is just the association. So as I said, these are just some examples. This is sort of what's called basically collaboration diagram. We talk about this class with abstract interfaces. It just tells you how people are related or classes are related. For example, an employee, remember these are sort of weak type of things. That means it's nice to have. When you typically, if you have a solid line, usually means association. Dashed lines typically means weak association, like I take a taxi, but I am in the same class with you would be solid line because you see each other every day, but I'm married to this student, you put a diamond on it. So this is kind of how we show these relationships and paths. Okay. So you've seen different types of it. So state machine diagrams, okay, it's kind of like those states and bubbles I showed you. Sort of resembles finite state machines, but usually allows for some local variables. It actually, one of the things that UML decided to do, which finite state machine didn't, they call it state transition. They started putting loops. You could have variables inside that one. For example, think of this. If you try to log into a system, okay, typically you could say in this state is connected to that state. This state says, are you a new user? Register. Are you an existing user? Log in. So when you want to log in, what do you want to do? Give your ID and password and log in. Well, what if you want to capture that I can only try to let you log in if you try it 3 times and you got it right. So I can maybe set a count equals to 0. When it says validate password, I'm going to say count less than 3. So let them try 3 times in case you fat finger your password. So this is kind of a nice way. So we could have loops and local variables and stuff like that in there. So if you've done UML, you know what I'm talking about. If not, this is exactly how we try to do this one. Also in UML, always solid circles means start, double solid means end. So when you end something, you do this. For example, I start, I'm going to say, is this a member of something? And I'm going to just keep a count. For example, let's say I want to add a student to a class. So open registration, maybe my class limit is 40. I'm going to say initially 0 people in the class. Say, add this person to the class. Every time I add it, I increment the number of people in the class. If somebody drops it, I will reduce the member until I get to my class limit, then I go there and clean up. So it's kind of a nice way of showing different things as far as that goes. These are, like I said, not that important. It's just showing you. I was just going to show you some models of how we do this one. Now, a manager will look at this one and said, okay, oh, this needs start goes this way, one could go that, one could go this. For example, let's think of a bill payment. Like you receive your electric bill, okay? And then you send it to the customer. So after a while, some customers send you the payment, some don't. So the ones that they send the payment, you give them thank you. The ones who don't send you a payment, you give them a reminder. Okay, so it's kind of that's how you know. First of all, you could tell your programmers, oh, please make sure to consider people who made a payment and the ones who didn't make a payment. And also you could sort of visualize how long it's going to take. So these are just different ones that we do have. Okay. We also have what's called interaction diagrams. These are called like sequence diagrams or interaction diagrams. These are not that important. I'm not going to question on these ones. So sequence diagrams basically actually when the order of event matters. For example, when you go to an ATM machine, the order of event matters. You cannot say give me the cash, then I'll give you my card. No, it says first give me your card. If it's a valid card, then give me your PIN. If it's a valid PIN, then tell me what you want. And if it is, so we could use this sequence diagram, which sequence comes from a time sequence that we show different things. Okay, so this is sort of a sequence diagrams. By the way, we call these swim lanes. That means this part belongs to the user, this belongs to the catalog, this is about the reservation. So I start, okay, let's say user wants to get a book. What is the first thing you need to do? You need to look it up. Right? You go to the catalog of the bookstore or library and look it up. So you find a title. If it's not available, maybe make a reservation. If it's available, you borrow it, and so forth. So you could just say, different entities or any. Let's look at the university. It's a little bit better for you. Let's say this is a student. Okay, this is course registration and this is payments. Okay, so you start. Okay, you look for a course. Okay, and when you look for a course, you just go ahead and register for the course. First you look at if it's available. Let's say course found. Now assume if the course is full or it's not offered, it's not found. So you look for a course. I'm just using my imagination here. I said look up for a class. Oh, it's not offered. Sorry, look for another class. Okay, this is offered, so register. Okay, and after you do a few of these, then you're gonna go and make a payment. Okay, so make a payment, check, credit cards, cash, whatever you're going to do this one. So, but notice you go top down as far as the time goes. As I said, these are sort of UML 101, which we don't want to do. This is communication diagram once again. Really nice diagram. I start here. I'm a user. Look at this arrow. Number one, I look up. This is exactly like this one. Okay. I use this sequence diagram. This is a communication diagram. Which one is better? They both are dynamic. You could show it different ways. It's kind of like a drawing. You could draw it one way or the other one. But the key thing is these 6 steps. Notice 1, 2, 3, 4, 5, 6. Like at the university, look for a course, register for the course, pay for the course. So you kind of need to have 3 requirements for this one. Here, for example, I start. First, I look for the course. If I find it, okay, great. If not, I'll make a reservation for later on, number 3, okay? And then the title is returned when that means somebody says, oh, your reservation is up, the course is available, hold it for me, and then I'm going to go ahead and remove it from the reservation list. So it's kind of like the way we show things. But the key thing for us is showing all the steps. So if you're sort of a manager, you could say, okay, this is what I need to do. I have 6 requirements. Maybe I have 3 employees right now on this project. Jeff, why don't you do a lookup and title? John, why don't you do these 3? And why don't you do the other one? Or if it's a login, maybe, Jeff, why don't you do registration? John, why don't you do existing user, Tom, why don't you do forgot password? And how long is it gonna take? Well, it's gonna take 2 weeks each, but you're working in parallel, so you're gonna say login will be done in 2 weeks with 3 people, right? This is how we use UML to estimate time and know how much to do or who's working on what. Another one is component diagrams. This is another one of the diagrams, so we're just gonna zip through that one. Sort of class diagram with the stereotypes. A stereotype is when you want to suggest something new or add something to a UML, call it the stereotyping. It's a way to identify sort of larger entities and sort of show modeling. So that important. So this is, for example, a component diagram. By the way, these little circles, we call it lollipops. Lollipop is how do you interface. For example, if a client or an employee wants to do something, okay? For example, if you need to buy some stocks or if you need to register for a course, well, MyMav has this system that registers for a course. You don't need to know anything about it. Like, MyMav could be 50 meg. All you need to know is the lollipop. In other words, what input do you need for me to provide? Okay, if you want to register for a course, I need your MAV ID. I don't need your name because name is not unique. I need your 10-digit MAV ID. Okay. Then I need the class information. And notice when you look for a class, it doesn't matter if it's a CSE 532500. It has a code that says A44946. So that's the code. And then of course it says a semester. It's fall 2020. So I will use this information and it does the magic for me. I don't care how it does it. It just does it, right? You don't need to know under the cover or when you need to buy stocks. What do you need to do? What is your ID as a customer, how many shares, what company, what price, and it purchases it for you. This is sort of how we show things. So all you need to know is what the lollipop wants, and lollipop means what do you need for me to interface with you, what is the input. So for example, if you go to an ATM machine, imagine this is the code for an ATM. You don't need to know how it does it. It needs a card, it needs a pin, and it needs an action like withdraw cash and the amount. So the moment you have that one, you enter it, it'll do it for you. Okay. And we also have a thing called use case diagram. Use case is a very popular thing in UML. That basically means it's a scenario based. For example, let's think of a student. Instead of saying a student register for a course, a student do this, a student do that, a student gets admitted, I'm going to make it to a scenario. For example, how does a student register for a course? So let's say this is you, and this is borrowing means registering for a course, or this one says the client borrows a book. So when I say how does a student, so the scenario is in here called use case, and you're the actor who uses it. Like, how does Ravi or a student register for a course? Now, this could be 10 different requirements, right? You could say, oh, you must be an active university student, you must have a valid ID, MAV ID, you must be in that department, that course should be offered, there should be room in that class, you should have the prereq for that class, and if everything is good, you register and then you have to make payments. So that's just simple question, how do you register for a class, will yield to these ones. So in use cases, we typically have the scenario in these circles, okay, and the actions by the user. So we call these actors. Okay, so think of a library system. So who are the client, employee, and a supervisor? Okay, so a client could borrow a book, or make make fine payments, like you're late, you need to make payments. An employee could order titles, say, hey, we need 10 more copies of this book, or collect fines. But an employee could also borrow a book. Okay, remember when I said multiple inheritance, you could be a librarian, but you could also borrow a book. So this is, you could see where the complication becomes. If you are an employee of a library, okay, and there's only one copy, there could be a conflict of interest, because then you put yourself on top of the list, okay, just because you have more privilege. Okay, so these are some of the things. All right, so in summary, this is really what I want you to get with this. you need to model things, you need to view things, you need to visualize things. When you visualize it, first you and your client talk the same lingo, you agree on things, you exactly see if somebody says, I want this chair, this is the shape of a chair, or this software, right? So we discussed some classical notation like entity relation, finite state, data flow, CRC, and of course the latest one is the OO notation called UML. So these are all different ones. Typically today, if you join a lot of companies, they tend to use UML. If you're some companies that are existing for many years, they might use finite state machine or data flow diagrams. So this is sort of a modeling chapter. Now you first remember, just 30 more seconds, we're done. When you want to do anything, first you need to model it. And then based on that model, you write requirements, and then you pass it for design and implementation. And as a manager, you have to manage the whole cycle. So if you could control this phase and eliminate redundancies or make sure everything is in your model, you'll be in very, very, very good shape. So that basically wraps up this chapter.